Hi, this is the data sufficiency worksheet, coordinate geometry. Those who have not solved the worksheet, solve it first and then come to this video for explanations. The link is given in the description for a complete review of coordinate geometry without the data sufficiency. This particular video is only solution of this data sufficiency worksheet coordinate geometry. No detailed explanations. All right. Only explanations, no detailed review of coordinate geometry topic, only explanations of this particular worksheet. Thank you. First question. Will a line with equation 3x plus 2y equal to 5 intersect a parabola having vertex at the origin? All right. So all we know is there is this line 3x plus 2y equal to 5. So if we write it in the y equal to mx plus c form, where c is the y-intercept, m is a slope, we get y is equal to negative 3 by 2x plus 5 by 2. Okay. So that means we have a negative slope of about 1.5. Yeah. And suppose this is 2.5, 5 by 2. And this is the line that we have. Okay. And we have a parabola at the vertex at the origin. So this parabola could be the red one, or it could be the blue one. Yeah. This end point of the vertex, meaning the u point, is the vertex basically. That's called the vertex. So as you can see uh, from my drawing, yeah, it seems it intersects in, whether it's U-shape it intersects and whether it's the blue one it intersects. But if I draw a pink one, yeah, then it will not intersect, right? So it depends upon which kind of parabola it is. Yeah. All right. So the parabola is an inverted U-shaped parabola. So when it's an inverted U-shaped parabola, yeah, it could be the blue one which is intersecting the line, or it could be the pink one which is not intersecting the line. Okay. So A, B, C, D, E. A is not giving a definite answer, so it's either B, C, or E. Statement B, the parabola is represented by the quadratic equation y equal to minus x square. So now we know that it is y equal to negative x square. Yeah. So then it is either the blue or the pink, not the red. Yeah. All right. So how do we figure it out? So all we have to do is look for any common point of intersection. Yeah. So as you can see this black line, minus 3 by 2x plus 5 by 2. Yeah. Suppose if I consider x to be somewhere here. Okay. Right. Okay. So let's take x to be 1. Yeah. So when x is 1, what is the value of y? When x is 1, y is negative 3 by 2 plus 5 by 2. So that is negative 1.5 and positive 2.5. So y is equal to 1. Okay. And we have this y is equal to negative x square. All right. So when x is 1, yeah, we get y equal to negative 1. So when x is 1, right, we took x as 1, right? For x equal to 1, we got this y equal to 1. So when we take x is equal to 1, yeah, this one, then the y value that we are getting is -1. So there is no common point out here, correct? So now we'll take one more point on the black line. Let's take this one. Yeah. So we'll take x is equal to 2. So for x is equal to 2, y is equal to -3/2 into 2 plus 5/2. So that is -3 plus 2.5. So that is -half, right? So then we plug it in here. So when x is -2, or sorry, x is 2, y is equal to -4. So the y value that we are getting is -half and -4. There's no so far a common point where x and y are both equal. So far we got x, we took it as 1, y was different, x is 2, y is different. So like that, you just test for 2, 3 points. So we'll try another point. Let's say this one. So this equation I'm saying is y is equal to -x square. Okay. Blue one we can ignore. Okay. Yeah. So we'll take y equal to x is equal to 3. So when x is 3, yeah, 1, 2, this is 1, 2, and 3. Okay. So when x is 3, we get y is equal to -3/2 into 3 plus y/2. So what we get is -4.5 plus 2.5, right? So -4.5 plus 2.5 is -2. Okay. And now when we take x is equal to 3 out here, then we get y is equal to -9. So they don't match. Are you with me? So then we come to know that clearly, will a line with equation this intersect a parabola having vertex at the origin? B statement gives me a definite no, it will not. Okay. So therefore, B is the answer, C and E is out. Okay. Right. Second question. Are lines A and B parallel to each other? Okay. Lines A and B have the same slope. So we know that when the lines have the same slope, then they are parallel to each other. So A answers. A answers, so B, C, and E is out. Equations represented by lines A and B have infinite solutions. So when they are having infinite solutions, they are identical equations. So you could say that they are parallel but coinciding. The lines are coinciding each other, and therefore they are parallel. Okay. So examples of this would be, y is equal to 2x plus 4 and 2y is equal to 4x plus 8. So although this is two lines A and B, but then if you multiply the first line with 2, you'll get the second line, or if you divide the second line by 2, you'll get the first line. Got it? So they're basically coinciding lines. Yeah. All right. So both A answers and B also answers. So D is the answer. That's a very basic question. Question 3. A circle is represented by the equation this, where HK are the coordinates of the point where the center of the circle lies and R is the radius. Find the solutions where x square plus y square equal to 4 intersects the line J. So x square plus y square equal to 4, if you see, it means h is 0 and k is 0, right? That means the hk are the coordinates of the point where the center of the circle lies. The center of the circle lies on the origin. Yeah. And the radius is r square is 4, so the radius is 2. So if this is my 2, yeah, then I have a circle, right, which approximately cuts through all these distance of 2. Okay. Yeah. So find the solution where x square plus y square equal to 4 intersects the line J. So I need to know what line J is. And once I get the line j, then I have to find out the solutions, which is nothing but the values of x. Okay. So line j has slope 0. That means it's a line which is parallel to the x-axis. It's a horizontal line and makes intercept with y-axis at 1. All it means is this red color line where at 1, yeah, you have a line with a slope of 0 and y-intercept at 1. Okay. So what this means is that this is y equal to 1 equation of the line. Okay. Right. So find the solutions where this, yeah, intersects with y equal to y line according to statement A. The description of that line has an equation y equal to 1. Okay. Right. Yeah, where the y-axis is at 1. All right. So this is your 1 out here. So every point on that line has the y coordinate 1, but the x coordinate is different. Okay. So therefore, it's called the y equal to 1 line. So we simply substitute the value of y in here. And so we get x squared plus 1 is equal to 4. So x is equal to 3. So, sorry, x squared is equal to 3. So x is equal to plus minus root of 3. Okay. So find the solutions. So solutions are plus minus 3. Okay. Yeah. So A answers. A answers, B, C, E is out. Second one, line J forms a chord on the circle at 2 points A and B with coordinates negative root 3, 1. So now let's say we ignore this line. Okay. Yeah. Let me go back. Yeah. So let's say we ignore this line. Now at 1, line J forms a chord on the circle, right, with coordinates negative root 3, 1 and positive root 3, 1. So these are the solutions. The x values are the solutions, basically. It is indirectly giving the explanation for A only. In A, we got x is equal to plus minus root 3. Remember, in A, the y was 1. All right. And out here, the y is 1. So it is directly giving us the solution. So D is the answer because each alone gives us the answer. Find the solutions. So solutions are, find the solutions where this circle intersects the line J. Okay, so solutions are minus root 3 and root 3. Both of them gives the answer, D. Okay, question 4. Is the point A with coordinate 2, 2 a point common to the two regions X and Y formed by the two inequalities represented in the coordinate plane? So we know that we have point 2 comma 2. So this is 1, this is 2, 1 and 2. So we have this point 2 comma 2 out here. So we have to find out, is this point a common point to the two regions X and Y formed by the two inequalities represented in the coordinate plane? Region X and Y is expressed by the following inequalities. So right now I showed you y equal to 1. So there is a y equal to 2. Okay. So this y equal to 2 is a horizontal line. Okay. Yeah. And it is lesser than 2. So everything, yeah. So we can say everything below y equal to 2. Okay. Now the question is every point on y lesser than 2, every point on this line is also part of this region? No. So therefore, it should be represented with a dotted line. A solid line indicates that every point on that line is a solution, or every point on that line represents y lesser than 2, which is incorrect. A solid line would indicate y lesser than equal to 2. If it's y lesser than equal to 2, then we have a solid line, right? So therefore, what we need is a, I'm sorry, yeah. So what we need is a dotted line, okay? So I'll draw a dotted line, right? Not a solid red line. So dotted line at y equal to 2 represents y less than 2. But if it was a solid line, the red line, then it would have been y less than equal to 2, which we don't want. Okay, because this inequality out here is y lesser than 2. And x plus y lesser than equal to 4. So x plus y lesser than equal to 4, I'll write it down in this form, y is equal to mx plus c form. So I know y is equal to negative x plus 4. So first I draw this line and then I'll talk about the inequality part. So negative x is um, a line with intercept y equal to 4, yeah, and a negative 1 slope. So this is probably the line that we are having, okay, out here, yeah. So as you can see, this is your 4 marker, yeah, this is your 2 marker. So this is your 1, 2, 3, and 4 marker. So this is your y-intercept 4, a negative slope line, yeah. Now, if you have to take region below that, then it will be everything below this, like this, correct? And the common region will be this yellow region, or I'll put it in green. This is the common region. The dotted one till here, yeah, and the solid one out here, everything, correct? Now, if you see, when y is lesser than 2, this particular point 2, comma 2, yeah, is a part of this region, but it's not part of y less than 2. This 2 comma 2 is a part of this region, but not including this. It's at the corner, very corner. So if it was less than equal to 2, then it would be a part of this. So is the point AA with coordinates 2 comma 2 a point common to the two regions, regions x and y? From statement A, the answer is a clear no, because out here on the side, now obviously my drawing was accurate enough to make it pass through the point 2 and 2, yeah. So we'll double check with equations. So this is my equation out here, yeah, and this is my y equal to 2 equation. Now if I substitute the y equal to 2 out here, yeah, so y equal to 2, what is the value of x I'm getting? That's what I'm wondering, okay. So x is equal to 2, correct? So now we look at this inequality, yeah, y equal to 2, we are getting x is equal to 2. Is it lesser than equal to 4? Yes, that is true. Now if I take y equal to 2, I can't take, I can't take y equal to 2 in the first place. Are you getting the picture? I can't take y equal to 2 in the first place, right? I have to take something lesser than 2, right? So let's take something lesser than 2. Let's take y equal to 1, okay? So if I take y equal to 1, then what I get is 1 is equal to negative x plus 4. So x is equal to 3. Now when y is 1, x is 3, it satisfies this inequality, yeah? And it satisfies this one. So my coordinates are 1 comma 3. So 1 comma 3 satisfies both of them, but when I plug in y as 2, yeah, this inequality is not satisfied. So therefore 2 comma 2 doesn't apply, okay. So we are getting a definite no out here. So A answers, B, C, E is out. Now point represented by the coordinates 2, 1 is the point common to the two regions x and y. So that could be true. Now as you can see, this is the point in pink I'm forming. This is the point in, let's take another color, blue. This is the point I'm getting, 2 comma 1, yeah. So it is definitely satisfying. So we'll take 2 comma 1. So I think we already took y as 1, yeah. And corresponding to that we got, corresponding to that we got x as 3, not 2. But whatever the case may be, this point 2 comma 1, yeah, it is within the region, yes. If this is um, um, 3 comma 3 comma 1, sorry, this is 3 comma 1, okay, yeah. So 3 comma 1 worked, yeah. If 3 comma 1 is satisfied, then 2 comma 1 will also be satisfied, okay. Yeah. So 3 comma 1 would be somewhere here. Yeah. Within that line. Okay. Are you getting it? Or probably on the line. It'll be probably on the line. Yeah. Because we worked out for the line and the inequality together. So it will be within the region. So point represented by the coordinates 2 comma 1 is the point common to the two regions x and y. So although 2 and 1 is a point common to the two regions x and y, it doesn't tell us anything about 2 comma 2. Yeah, it doesn't tell us anything about 2 comma 2. And one more mistake I made, again a great incorrect assumption. So I explained you know this 3 comma 1 explanation I used for this one, yeah, which is incorrect. Yeah, I mean, I shouldn't have used statement A to explain statement B. So on its own, without the statement A, so if I just remove the statement A, yeah. Now, if I look at this, can I solve it? Is the point A with coordinates 2 to a point common to the two regions x and y formed by? So point represented by the coordinates 2 1 is the point common to the two regions x and y. That is true, but it doesn't help me explain or you know tell me whether 2 comma 2 is a point common to the two regions. Without knowing the inequalities, there's no way I can figure that out because I don't know the regions overlapping. I don't know the equations, inequalities, nothing. So B doesn't answer. Yeah, B doesn't answer. So therefore only A is the answer. B is out. Okay, A is the answer. Right. On to the fifth question. So again, guys, remember this is for advanced learners. So all those who are getting confused with my explanation, well, one thing is that I'm not explaining it well. That's why you're getting confused. Second is that probably you just need to, um, you know, comment in the video and have a session with me so I can explain it to you. Yeah. Consider an XY plane where the point 89 is shifted by 40 units horizontally and 60 units vertically. Find the position of the origin if the shift took place for the entire XY plane, meaning all the points within the XY plane shifted. Yeah. So if the shift and this shift, so 40 units horizontally, 60 units horizontally, the entire XY plane is shifting. So as far as 8, 9 is concerned, yeah, all right. Now they've not told us whether the 40 units horizontally is on the left hand side or right hand side, 60 units is whether up or down. So this question on its own, question stem on its own, doesn't answer, which is correct. So we have to look for the information A, B, C, D. So A information gives us the shift. By looking at this negative 32 from A, we know that 40 units is gone towards the left. And looking at 69, yeah, we come to know that the vertical shift is up, right? So now we know that the origin, therefore, which was 0, 0, yeah, since the entire xy plane also shifted, so the origin now will be at minus 40 and plus 60, correct? So find the position of the origin if the shift took place for the entire xy plane, meaning all the points within the xy plane. So A answers, B, C is out, correct? Now after the shift, the origin lies on the line y equal to 60. Now remember, we cannot consider the first statement, right? So we leave it out. Yeah. So looking at this, yeah, we have to find out the position of the origin if the shift took place for the entire xy plane. Yeah. So we know it moved 40 horizontally, but we don't know left or right. But the B statement, from the B statement, we come to know, yeah, that the origin which is on 0, 0, yeah. So after the shift, the origin lies on the line y equal to 60. So there's this line y equal to 60. So let's assume the y equal to 60 line is here. Yeah. right? So now we know that after the shift, the origin lies out here, which is telling us this part, but we don't know the 40 units horizontal shift. So we don't know whether it's on the left hand side or right hand side. Correct? So B doesn't answer. A is out. I'm sorry, D is out. Yeah. So only A answers the question. Yeah. So this one directly gives us the this one tells us that the shift is to the left and up. So therefore, from the origin, we go left and up and we get it. Second one only tells us it's up. It doesn't tell us where on the y equal to 60 line the point is. The 40 units on the line 60, y equal to 60, where is it? It doesn't tell us that. Yeah. So it doesn't tell us whether the origin is here, the 40 unit shift is here, or 40 unit shift is here. Are you with me? Yeah. So only A answers. Sixth one. On a grid map of XY plane, city A has coordinates 612, city B has coordinates minus 410. Yeah, so we'll draw a grid. That's a XY plane, grid map, whatever you want to call it. Yeah. So 612 is 6, 12, 6, 12. Yeah. So we have 6 here and 12 here. So this is our 1 point and minus 410. So if this is my 6 and 12, minus 4 is somewhere here and 10. So this is 6, 12. So 10 is somewhere here. Okay. Right. So this is city A and this is city B. If grid map has an area 4,000 square kilometers and the coordinates represent the distance in kilometers from the origin, meaning these coordinates are in kilometers, then find the area represented by city A. So city A has what area? So A, B, C, D, E. Correct. City A has a circular area greater than 50. So city A has a circular area greater than 50. So, you know, we know that if this is equal to 50, then it's greater than 50. We don't know how much greater. So we don't know whether it's still here, till here. Yeah. We know it is more than 50. If this is 50, then we know it is more than 50, but we don't know how much more. Yeah. So A doesn't answer. D doesn't answer. It's either B, C, or E. The horizontal distance between city A and city B is equal to the diameter of the area represented by city A. So the horizontal distance, so A has the coordinates 6 and 12. B has the coordinates negative 4 and 10. So if you have to find the distance between them, it is root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So that is root of 2 square and 10 square. So that is root of 104. Right. And that is the diameter also. So the horizontal distance, sorry, the horizontal distance, not the distance between them. So the horizontal distance, my bad, I actually found out the distance between them. Yeah. So although the line looks horizontal, it's not really horizontal, it's inclined. So the horizontal distance is only the distance between 6 and negative 4. Right. So that is the horizontal distance is 10. Yeah. So that is also the diameter of the area represented by the city A. So that directly tells us, then find the area represented by city A. So the area represented by city A is pi r square, right? And the diameter is 10, so radius is 5. So that's pi 25 square kilometers. Okay, gives us the answer. The B gives us the answer. CE is out. Okay, yeah. 7. Does the line that passed through the point MN have a negative slope? Right. So we'll draw the grid first, the XY plane. Okay. So point Mn have a negative slopes. Line passing through the point Mn have a negative slope. So the line that passes through the point Mn passes through the quadrants 1, 2, and 4. So it passes through 1, 2, and 4, but not 3. So clearly the line is this one, 1, 2, and 4, not passing through 3. It can't be anything like this, because then if you take it like this, then it passes through 3, 1, and 4. But it says 1, 2, and 4. So if it's passing through 1, 2, and 4, we directly get the answer that it has the negative slope. Now, for those people who are wondering, how am I just looking at the red line and saying it's a negative slope? So usually, if you want, you can simply say that if it forms an obtuse angle, meaning greater than 90 degrees with the x-axis, yeah, then it is having a negative slope. And if it is having an acute angle, meaning something like this with the x-axis, that's forming a positive slope. So let's say that somehow the line is shown only so much. So they just show you so much of the line. Then either you extend it and then form an angle and check. If it's obtuse, it's negative slope. Yeah. Or what you could do is you can simply, if this is the portion of the line shown in the diagram, yeah, then you simply take a line parallel to the x-axis and then form an angle and check. Okay. Right. So if it's passing through 1, 2, and 4, then we know it is having an obtuse angle and the slope is negative. So does the line that passes through the point Mn have a negative slope? Line that passes through Mn passes through the coordinates 1, 2, and 4. So this is already saying it's passing through Mn. So we already know that the line passes through mm, and we already know that using 1, 2, and 4, it gives us a negative slope. So yes, it does. So A answers. B, C, E is out. Yeah. So it's either A or D. Yeah. All right. The product of M and N is positive. So now see, point Mn, the product is positive. Now we know that in the first quadrant, both the points are positive. In the second quadrant, both the points are positive, negative. Third quadrant, both are negative. And fourth quadrant, both are positive, negative. I'm sorry, negative, positive. So if the points are negative, positive, positive, negative, the product will be negative. So we know that the point Mn, where the product is negative, I'm positive, is either lying, the point Mn is either lying in the first quadrant or the third quadrant. All right. So if it's lying in the first quadrant, then we know that Mn is both positive. If it's lying in the third quadrant, then we know that Mn is both negative. So if Mn is both negative, I'll use a blue color for the lines. So one line that we can get is this same red color line, and we can know that the slope is negative. But what if it's both negative and the line is passing through like this? All right. Also, the fact is, if Mn is both positive, yeah, because the product of Mn is positive, not necessarily it could be like this. Now it could be this green color line also. Now, suppose if I take this as my point Mn, yeah. So who says it has to go negative? It could go positive also. Now it could go like this also, right? Because we have to ignore the first statement, right, while solving the question. So this green line has a product Mn and positive, and it's showing you with the green line, I'm showing you it has a positive slope, and with the blue line out here, I'm showing you it is a you know negative slope. And similarly, if the Mn point was here, let's say, yes, so I could very well draw another line like this, passing through Mn out here. So it's a yes and no situation. Okay, so B statement doesn't answer the question. Only A does, so D is out. A is the answer. Okay, yeah, right. I'll just double check my work. Hang on. Okay, eighth question. Find the perpendicular distance between two parallel lines J and K. Yeah. So, see, there are two ways to solve this. One is directly using the formula. Yeah. Or you can use the same formula like this. So this is the formula to be used when you have the equations written like this, and this is the formula to be used when you have the equations written like this. Yeah. Ax plus by equal to c form, use this formula. If you have the equation in this form, use this formula. I prefer this one. Yeah. It doesn't matter. It's just the same thing at the end of the day. So find the perpendicular distance between two parallel lines J and K. So first I'll show you this method using the formula. So lines J and K have slopes equal to 3. So with slope equal to 3, we don't know the y-intercepts, right? We don't know the y-intercepts. So A, B, C, D, we just know that this, the lines are parallel, which is already given in the question stem. And we now know that the slope is 3. So it just gives us the denominator value. It doesn't tell us the C1, C2 value, correct? So A is out, B is out, B, C, or E. Statement B, line G and K have their y-intercepts at 4 and 9 respectively. So now we got the two intercepts 4 and 9, correct? Yeah, but it doesn't tell us about the slope, what slope it is. So B also doesn't answer. But when we take both together, then we have the slope also, which is 3. We have this 4 and 9. So the perpendicular distance is C1 minus C2 upon root of 1 plus m square. So that is 4 minus 9 mod upon root of 1 plus 3 square. So that is mod of negative 5 upon root of 10. So that is 5 upon root of 10, which can also be written down like this: root of 5 into root of 2. Root 5 goes into 5 root 5 times upon root 2, or basically root of 2.5. Now the reason I could stop here, but I went on to this, and this, because now when I solve it without the formula, yeah, when I solve it without the formula, I'll get this response, or I'll get 10 by 4 response. That's why I want to break it down further like that. Yeah, because root of 5 upon root 10, you won't immediately come to know it is root of 2.5. Yeah, or root of 10 by 4. Understood? So I had to break it down to show you that's this. So now we work on the second, without the formula. All right, how the C happens without the formula. So let's solve it without the formula. Okay, so let's assume this is my y equal to uh, line J and K have their y-intercepts at 4 and 9 respectively, right? So this is my 4, yeah, 9 intercept, and this is my 4 intercept. Okay, let's shift it up a bit. Okay, so that's my 9 and that's my 4, right? And the slope is 3. So let's give it equation y equal to 3x plus 9, y equal to 3x plus 4. Correct? Right? Okay. These are the equations I get. Okay. Now I need to find a perpendicular distance. So let this out here be the perpendicular distance between two parallel lines J and K. Yeah. So this is the x part that we need to find out, right? Or let's call it a different letter m, n. Let's call it n. So this distance n I need to find out, right? And since it's perpendicular, yeah, right, to both the lines J and K, it is perpendicular to both the lines J and K. Yeah, right. So J has slope 3, K has slope 3. So any line perpendicular to this one will have a slope of negative 1 by 3. Correct? Yeah, right. So it's a rule. Perpendicular lines, slopes, product of the slopes of two perpendicular lines is equal to negative 1. So if I know one slope is 3 and I need to find an m2, then I simply use this expression and I get m2 is equal to negative 1 by 3. And that's how I got negative 1 by 3. Okay. So now I know that this particular line segment has a slope of negative 1 by 3. So I'll take it as negative 1 by 3x. Yeah. Plus 9, because if I use this itself as the intercept, then that's my equation. All right. Now I already know the coordinates of this point out here, which is 0, 9 actually. Yeah, 0, 9. I need to know the coordinates of this point. Yes. Yeah. So in order to know the coordinates of this point, I'm going to solve line K, which is y is equal to 3x plus 4, along with this line N, which I found out, this one. Solve it simultaneously, and I get 3x plus 4 is equal to negative 1 by 3x plus 9. And so I get 3x plus 1/3 x, which is 10 by 3x, is equal to 5. So x is equal to 15 by 10, which is 3 by 2. Yeah. If x is 3 by 2, then from here or here, I get my value for y. So I'm going to use y is equal to, yeah, 3x plus 4 to get the value of y. So x is 3 by 2. So what I get is 9 by 2. 9 by 2 is 4.5, and plus 4 is 8.5. 8.5 is 7 by 2. 17 by 2. Yeah, or 8.5. Okay. Yeah. So now I know my points are 1.5, yeah, and 8.5, like that. And I know this is 0, 9. So I can use the distance formula. Distance between 0, 9 and 3 by 2 and 17 by 2. So the distance formula is very simple. Root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So x2 minus x1 the whole square is what? 0 minus 1.5, right? The whole thing squared, right? So that's 9 by 4 plus 9 minus 17 by 2. So 9 minus 8.5 is half whole square. So 1 by 4. So what I get is root of 10 by 4. And root of 10 by 4 is root of 2.5. Or in other words, root of 5 upon, I think it was root of 2, right? Or root of 5 by 2, however you want to put it, which is the same thing as 5 upon root 10. All of these values are the same thing. Okay. Yeah. So 5 upon root 10 is what we got using the formula. So this is just another way to get to the answer if you forget the formula. But the fact of the matter is that all you need to figure out is that can you solve the question? You don't have to get to the solution. You don't need to get to the numerical answer. Anyway, question 9. So yeah, the answer is C. You already know that, yeah, for the eighth one, ninth one. So line N is perpendicular to line M, okay, and has a slope equal to the slope of line R. So the question is find the slope of line M. So line N is perpendicular to line M. So let's say this is line M, okay? So line N is perpendicular to it. So let's say this is line N. Perpendicular to line M, okay? So does it tell us anything about the slope of M? Nothing, right? So statement A doesn't answer. So D is out. It's either B, C, or E. Now statement B. Yeah, just hang on. Okay. So from A, we don't get the answer. Now look at B. Line R is parallel to line Q, which is perpendicular to line S, which has a slope equal to 4. So see, R, Q, and S are lines which are not related to M, right? So we can't figure out what is the slope of line M because second statement doesn't talk about line M or any relationship of R, Q, S with M. Yes. So B is out. But when we take both together, yeah. So this is from statement A. Now when we add statement B to it, that is line R is parallel to line Q, yeah, which is perpendicular to line S, which has a slope equal to 4. Yeah, right. So we know that line N is perpendicular line M and has a slope equal to the slope of line R. So this one, the slope of N, yeah, is also the slope of R, right? So as of now, we know that M has a positive slope and N has a negative slope, whatever the case may be. So slope of N is equal to the slope of line R. Okay. Now what is R? R is parallel to line Q. Okay. So it is parallel to line Q. So I'll draw it with a green line, line Q. Yeah. So that's your Q. Okay. Parallel to line R. Line R is parallel to line Q. And line Q, which is perpendicular to line S. So another perpendicular. So I'll draw it with the red one. Yeah. So this is your S. Yeah. And it has a slope of 4. Correct. So as you can see, yeah, this S is parallel to M. And when two lines are parallel, we know that they have the same slope, right? So M is equal to 4 is also the slope of M. And hence, what is the slope of line M? We come to know from both statements together. Okay. So C is the answer. Last one. Line K does not pass through which quadrant? Okay. So these are the first, second, third, and fourth quadrant. Yeah. Line K has a negative slope and x-intercept at minus 50. So this is my negative 50. And it has a negative slope. So if it has a negative slope, then the line will form an angle greater than 90 degrees. And as you can see, this line with a negative slope with x-intercept at negative 50 will not pass through the first quadrant. So A answers. So A answers, B, C, E is out. Either D or A. Now second statement, line K is perpendicular to line J, which has a positive slope. So what we do is we once again, yeah, jot down first, second, third, and fourth quadrant. Yeah. And we only look at the second statement, not the first one. Line K is perpendicular to line J, which has a positive slope. So suppose this blue color line is line J, which has a positive slope. Yeah. So this one has a perpendicular line K is perpendicular to line J. So this red color line or yellow color line, we use it as perpendicular to J. And this perpendicular could be like this also, right? So as you can see, this K, if it's the first one, K1, then we know that it will not pass through the third quadrant. But if it's K2, then we know it will not pass through the first quadrant. Hence, we can say that B statement doesn't give us a definite answer. So D is out. It's only A, right? A is the answer. Only A answers the question. And with that, we are done with this coordinate geometry worksheet. And thank you very much. Stay tuned for some more data sufficiency worksheets. Description of this video gives you the links to all the channels, yeah, and the worksheet. Thank you.